equations, and then you can plug them into the calculator. So for the first one, it asks for the volume of the solid generated when R is rotated about the horizontal line. So basically, to solve this, you need to take the integral of r squared, big R squared, minus little r squared. So to find this, big R is equal to the greatest distance between a function and the whatever line it is rotated about. So we have basically we have the line of y equals 4 in the function, and then the graph of x to the fourth minus 2.3 x cubed plus 4. So as you can see here, as shown, the distance from the horizontal line of y equals 4 to -2 is greater than, obviously, the distance right here from the line y equals -2 to the region R, or to the function f of x. So with that, you're able to determine which one's big R, which one's little r. And now, in doing so, you want to do, it's basically, you set this up, you do the integral of 0 to, and as you can plug in your calculator, x is equal to 0 at 2.3. So here's it. We're going to get from there to there because that's where the 2 points that they meet. Then you're going to do your function of the line of y equals 4. Now keep in mind that the horizontal line is a negative and it is below the function of y equals 4. So instead of it being subtracted, you're going to add. So you do 4 plus 2 squared, so that's big R, minus the function f of x, which is given to you. So you can just write it like that, plus 2 as well, because that function is above the line of y equals -2. Square that, and put it in terms of dx. And basically all you're going to have to do here is, you would plug this into your calculator, and I can show you how to do that. So basically, to do this, you would go into the calculator, and you're going to get a y equals, plug in the function, so do x to the fourth minus, okay, I'll show this after, 2.3 x cubed plus 4, and then you do 1 for your horizontal line of y equals 4. And now, to solve this, you are going to go, and by the way, this is multiplied by pi on the outside as well, because that's the formula. And you're going to do pi times the integral of 0 to 2.3 of the function y bars. For this part, you're going to do the function for y equals 4 plus 2, square that, minus the function y1 plus 2, square that as well, and leave it all in terms of x. Now all you have to do is just hit enter, and we get an answer of 98.88 or 98.868. So that's all you really have to do. for that part, pretty simple. And you're just going to write 98.868. Here's your answer to the first part. Now for part B, it asks for each, find the volume of the solid with each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. So the way you want to draw this is you can draw a little triangle in here. And obviously with an isosceles triangle, the two sides are equal. Now, the formula for the volume for an isosceles triangle is 1/2 times the base squared. Now the base is going to be the top minus the bottom. So basically you're just going to be doing, and that's the thing for the area, I mean. So to find the volume, you're going to have to do the integral of that area. So again, you're going to be doing from 0 to 2.3 because that's where the intersection occurs. And you're going to do 1/2. Should you see that? So 1/2, and the base is going to be the top minus the bottom. So your top function is still the line of y equals 4. So you'll do 4 minus, and then f of x, which is your function on the bottom. You're going to square that, and then put it in terms of dx. And again, all you really need to do here is just plug on into the calculator. So you can do basically do 1/2 times, and again do the integral from 0 to 2.3 of vars y2 minus, let's put that one on, vars y2 minus y1, square that, as the formula tells you, and you're just going to put it in terms of x again. And again, all you need to do is just hit enter, and you come out with an answer of 3.574. Again, like you said, you don't have to show all the work here. You just got to set it up, and the calculator can solve it for you. So that's all you do. Now, for part C, it says there's a vertical line of x equals k that divides the region R into 2 equal areas. Write but do not solve an equation involving the integral expressions whose situation gives the value k. So basically it's saying that there is a line that cuts through here, it's vertical, and it splits that region R into 2 equal regions, and we need to develop integral expressions that would give the answer to the value of k. So basically, if you're thinking about it, since it's going to split this into 2, you're going to go from first, and by the way, when you're solving for integral expressions to equal something, you're going to come up with 2 expressions and set them equal to each other to find that value. So basically, for this part, you're obviously going to be going from 0 to whatever k may be. So your integral will be from 0 to k because that region is split by the so-called value k at whatever x is equal to. So, and for that, again, you're just going to be finding out, you're going to do top minus the bottom, that you've done in the past, to find that area. And in terms of dx, now set that equal to, now for the next part of this equal area, you're going from k to 2.3, which is where 2.3 obviously at the x value where they meet again, where the two functions meet.